going to combine two sessions into one. It's Friday afternoon. Some of you still need to catch a plane today. So I'm going to combine actually two sessions into one and then try to keep it a bit interactive. So I think, yeah, we discussed it before. We have the VPU, see it as a power, as the engine, SCALSTRM, the software on top of it, where the magic happens. And what we want to show today actually is a bit what's under the hood, how we use the VPU, what's done in CPU, so a bit how we handle it. I think we discussed a bit who SCALSTRM is, so let's skip that part. Mainly the VPU, we want to use it for cost efficiency, scalability, and yeah, especially the high density in channel count, I would say. We also want to use all the features and the whistles and bells from the VPU card as much as possible. It doesn't make sense to do it twice in hardware or in software, so that's we want to use all the whistles and the bells from the VPU card and add on what is missing or what makes sense in terms of redundancy, resilience, and so on. So also what we've seen based on experience, FFmpeg, FFmpeg GStreamer, it's natively supported on the VPU cards. It might be great, or it is great for offline jobs. What we've noticed in broadcast live workflows, yeah, there's more to it than just transcoding. And I think that's where I think we step in. So there's things you need to handle, frame repair, synchronization. You need to build a carrier-grade system with FFmpeg. It's a great tool. I think everybody in this industry knows FFmpeg or have used it in some form. But in a live flow, there's much more to it. And then actually we've seen it with a live example where initially the customer was using the VPU cards together with FFmpeg for their live flow. Then again, there were channels that had issues coming from satellites, from third parties, from other companies, from cameras, different feeds. Some feeds had more issues than others. And then, yeah, it was quite clear the FFmpeg flow couldn't really handle all these errors and just make it work. So that's when we stepped in. Actually, we learned a lot. This is already some time ago, so it's not that this is quite fresh. So we learned actually a lot. The best way to learn is to jump into it and run into issues, because then you know what to solve, and other customers, partners can benefit from the issues we experienced there. So in the meantime, I think I could say we have a quite rock solid live workflow. So also one thing that I would like to highlight, you have the transcoding job, and afterwards typically you have the packaging job, the origin. On our side, we have combined the two. So you have vendors that do transcoding only, you have vendors that do packaging only. Our packaging solution was already really resilient, and I can do frame repair, synchronization coming from third-party transcoders. So what we have actually done is we have combined these two solutions to make it even better. In that sense, it's kind of a combined solution. In some cases, it might make sense to do transcoding only, but in a typical workflow, then we have our transcoding job and we have our packaging origin, and combined together, it's a great tool. I would call it like that. Also, it's a single management system for the transcoding, for the packaging, for the shield, or for the CDN, whatever you use. It's one single UI, and of course, as shown in the previous session, we also have an API call where you can manage everything independently. So if we take the pipeline, then on the input side, either the MPEG-2 TS stream, an SRT, or RTMP feed that we get in. Then actually the VPU magic is happening here. Everything else you see on the slide is actually done by on our side in software. So we do depending if it's interlaced or not, we do the deinterlacing, we do the decoding, then we do all the filtering, upscaling on our side in software. On the processing side, we can insert the logos, apply watermarking, AB watermarking, timecode, slates, subtitles. That's all handled on our side, on the pre-processing side. Then we feed the frame by frame, to the VPU card, where all the transcoding is done, HEVC, AVC, or even AV. And then we get the frame back, and then we actually pass it on to our packager, and there we can do synchronization, frame repair from the other feed, and stuff like that. On the audio side, there's no audio transcoding in the VPU card, so it is actually passed through. And on our side, we do have audio transcoding, so we can transcode AC3 to AC to AEC, and then MPEG to AAC. So this is done on our side as well. So as you can see on the slide, using FFmpeg only, that would be this part. There's much more to it than just using the VPU cards, especially when it comes to a live flow. So if you look at, yes, it's actually the same slide as before, but a bit in a different view. If you take the input side, until we feed the frame to the VPU card, all that is done in CPU. So we do the demuxing, splitting up of the video, subtitles, audio. Then we have all the video filters, the interlacing, frame rates. And actually this is a kind of plug-in architecture on our side. So if we need to have multiple or different video filters, we just plug it in, develop it, and then plug it in the architecture. So it's really straightforward for us to develop new features if needed. And then on the processing side, the subtitle overlay, the logos, the repair. It's kind of plug-in framework that we use for that. Then we feed the frames to the VPU card. This is done frame by frame. So of course we have a queue to handle that. And then the scaling, the encoding is done by the VPU card, and then it's it's given back to the CMF output to our packages. And then on the packaging side, then we have the regular flow where we can handle also synchronization. And then we also have other concepts which I can quickly mention in a short demo. A bit on based on experience, what we figured out. Why FFmpeg is not the right tool for a live flow, at least not in most cases. In some cases it might work, but in most cases not. What we figured out is, one input feed is better than the other. What we've noticed is that there are a lot of input errors, repeated frame, we need to repair frames. This is definitely something that not every input feed is as good as it should be. So therefore, I think you need to be able to handle input errors and repair it, synchronize it, and so on. Another thing, what we do is we handle frame by frame, so individual frames, not actually a full stream. It's frame by frame, and by doing that, this also allows us to, for example, Scooty 35, we can detect these. And use them for whatever we need it. We can do a frame accurate slate insertion. The same on the muxing. We have to do frame accurate muxing between different streams. And that's the main advantage by splitting it up and handling it frame by frame instead of using a stream. And of course, we fully optimize or we fully utilize the power of the VPU cards, and that makes it as a total solution very cost efficient. And then, of course, the whole flow is either UI-based or API-based. So perhaps let's jump back to the demo to go into a bit more detail than we did before. So if we go to the live transcoding, I think before in the demo we used, I think this one, this profile. So we can have sorry, go ahead. So we can have different templates. Of course, you can assign a template when you configure a channel. This is the template we used for the demo before, transcoding into 4 profiles. We can just configure it as we like. And then, of course, this is where you can configure all the different settings. I don't think it makes sense to go all different settings, but here you can configure the hop size, bitrate mode, CBR, capped CRF. We can handle 2-pass different levels of transcoding, encoding, and actually this is also something that we enhanced along the way. Initially, together with NETINT, I think we have a really good relation. And then we detected that sometimes features were missing, or that some features needed to be activated per channel, not as a general setting. So this is something that we learned based on experience from customers. And then together with NETINT, we have a quite tight relation. And then some features instead of a general setting where it was possible to configure it by channel. And this is something that we can apply now in the UI. So everything that, all the tuning settings that you can apply on the VPU card can also be applied here. For you, it's quite transparent. For you, it's transparent if in the background it's done in CPU on our side, or if it's done in the VPU. And to be honest, you shouldn't worry about it as well. So if we create a channel from the UI, then you will see more what's going on in the background. So either in the past we supported on the packaging side MPEG-2TS, SRT, CMAF, ingest. These days we can always actually already quite some time to use our own transcoder. So in this case we just take an MPEG-2TS stream, UDP input stream. For some who know our system, Blacksmith is a microservice that's new, that's a transcoding job. And then form is the ingest, which is the same as on the packaging side. So it's just a flow in before that changes. So let's take the same profile again, the 4 profiles for the video. For the audio, we don't do any transcoding, we just pass through. And then on the output, there are also some things you can set. If you want to do it in software or if you want to do it in hardware, if the stream needs to be actually not this way, deinterlacing, if you need to do deinterlacing or not, this is something that we can configure here. Then we can also assign a template. So you can have multiple templates, and in this template you can set everything you need. For example, if we have let's say a sports channel, then we enable low latency.
No, we have one optimized interlacer as of now, but as Dominique said, we have a plug-in system for developing new things. We are looking at more advanced interlacer later on.
Then CPU result or consumption of that will be fairly high, I guess, in the future if they are more advanced.
Depend on what more advanced means. And the CPU consumption as of today is 0.7 of 70% of the CPU core if you're running it.
It's a bit of a design thing. So this is something where we help our customers, our partners, because indeed, if we need to do the deinterlacing, it's done in CPU, then we need to design the hardware slightly different than if it's progressive.
Yeah, I mean, other solutions typically really will have the advanced ones. They will consume more than encoding itself. So if it's a software, so I mean, then again.
No, but that's a kind of design question, and that's I think our team can help. Probably not myself, but the team can help for sure. So then you assign the template, and then all settings are set. Low latency, net insertion, time shift TV, whatever. Here we can also do the enabled synchronization. So this is a feature that's then on the packaging side, not on the transcoding side in that case. So this is the synchronization, just to make sure that both feeds are 100% in sync. In this case, we have only one system, but channel placement, you can say, okay, this is a pop-up channel, I want to deploy it in the cloud. Then you just deploy it in the cloud. Actually, it's here. And you can apply it here. And then we can publish it. So if we apply transcoding, so it will detect immediately. It will start the transcoding job in the background, similar like we launched with API. And then the channel is again up and running in, I think it takes 2 frames, something like that, 2 or 3 frames, and then the channel is up and running. So that's a bit what's happening in the background. So for you cannot really see it in the demo. What's done in CPU, what's done in VPU. But I think, key takeaway is that the combined solution as such, it's a carrier-grade solution. I think that's the key takeaway. Using the VPU with our software, that's the cost efficiency where it comes in. So that's a bit what I wanted to highlight. In short, I give you at least a bit of a background of what we do, I think. So this is, let's say, what's going on in the background. And as you see, some of it is done in the VPU side, some of it is done on the CPU before even the VPU. And then you have our packaging solution behind it, which makes it a good combination. So that was a bit what I wanted to explain. Any questions, feel free. If not, we are here. You can talk to us after or give us a call. Bye. myself. I'm not from Sweden, but Will and the team, they can help you out with deep technical or more